Hello, hi guys. So in this video, let us prove the function does not belongs to any object. So function is not a part of a object. So that is what we are going to prove today. So here I have an example. So here you can see the class name is a point and it is having one public function which is print, and it is printing the value m underscore x and m underscore y, which is a private variable, and I have initialized to 1 and 2. So when I create a instance using point p, and I'll say point dot print. So what it does is, so it is creating an instance, and using that instance, I'm calling this print. So this is what we see. But internally, it does not happen like that. So if you have 100 instances and all the 100 instances will share the same function. So that is what it means. So that means have a single copy of a function which is being shared across all the instances. So let us prove whether that is right thing or not. So for that, like what I'll do is, so I'll try to print the address. I'll say cout, I'll say address of p is equal to address of p backslash n. This is what I'll print in main. And also here what I'll do is, I'll say std out, this is equal to this. So that means I am printing this. What is the content of this? So I am claiming that it is the address of p. So let us see. So I'll say g++ main.cpp, and if I execute a.out, can you see? So 2AA D0 and 2AA D0. So both the addresses are same, right? But how would this one works? So what compiler does internally is, so it will call this print function, and first argument it will pass as address of p. So this is what it internally converts. And also whenever during the compilation, what it internally happens is, so this function will be converted something like this. So I have a point star, and I'll say const and this. So this is what it internally converts. Whenever the const comes after this star, right? So that means this cannot be point to something else. So that means in between I cannot do something like this. So it may be pointing to, let's say I'll create one more instance. I cannot say something like this. So this is not allowed because it is a constant. And also they made the variable name this as a keyword in C++, so that it gives a feeling that this is a thing which points to this. So this is very much intelligently they have selected this variable name. So then what I'll do is, so now we had seen this one, this is how it works, right? So now let us prove this one by using a GDB. So for that, what I'll do is, I'll compile this one using -g3. So when I do this -g3, it will also store the debug information as well. And also along with the source code, line number, and all those things will be stored in a.out. So now what I'll do is, I'll use GDB a.out. And also I'll put a breakpoints on line number 9 and line number 19. So let's put a breakpoint on line number 9. And also I'll put a breakpoint on line number 19. And if I execute this one, so this is where the point p is being come, right? So when I say next, so it has created an instance of point p. I'll try to print the address of p. Can you see? So it is DFF0. So then what I'll do is, I'll say next. So it has went inside this function. So it has went inside this function, and the breakpoint we have set on line number 9. So it is stopped over there. And can you see what is the first argument? So the first argument is nothing but this, and the address, can you see, DFF0. So this is what the address of p, right? And also can you see, so it has converted into point star. So it has converted into the type which is of point star. So that is the address of p, right? So then what I'll do is, I'll try to print this. When I try to print this, can you see? So what is the argument type? Point star const. So point star const and this. So this is what it internally converts. So can you see both the addresses are same? So that means we have proved that one. The point, this print function does not belongs to any instances. Rather, the address of the instances is being passed as a first argument, and it is mandatory. And that name is nothing but this pointer, and the name of the variable is this, and which is hidden from the user. But what if I try to create an instance in a heap location? So let us try to look. What I'll do is I'll comment out this one. I create point star ptr is equal to new point. So then I'll use this ptr to call this print. So here what I'll do, instead of address of p, I have to put ptr because ptr is already pointer, right? So this is what I'll do. Now if I try and compile and execute this one, a.out, can you see both the addresses are eb0 and eb0. Now what I'll do is, so how it internally works is, so it will call this print, and earlier it was passing, it will call this print. Earlier it was passing address of p. Now it has to pass only ptr because it's already pointer, right? So this is how it internally works. Similarly, even constructor. So whenever I say this constructor, no, the constructor is also a function, but the name of the function is same as the name of the class. And the first argument of this constructor is what? So that is nothing but this pointer. So that means whenever I say point p, this internally calls the constructor. So let us try to analyze that one as well. So I'll say constructor \n. Now what I'll do is I'll compile this one. I'll try to put a breakpoint at line number 9. So I'll say gdb a.out gdb a.out. So gdb a.out. Let us put a breakpoint on line number 9. So this is what it is. And okay, so we did not uncommented this one. So what I'll do is I'll uncomment this one and let me comment this one. So let us make the problem simpler. So I don't want to directly go into the heap stuff. So I'll quit. So let us compile and put a gdb and breakpoint on line number 9, and let us put breakpoint at line number 25. Now if I try to run this one, can you see? So it has been gdb is waiting here to execute this one. I'll say next. As soon as I say this next, right, can you see directly it has went and jumped to line number 9. When I try to print the address of p, so here it is not present because it's already been called. The constructor is already been called. So the constructor is called and the address is this one. So in order to go to the next line, let us put next. Now if I try to print address of p, so it is still not went there because brace is there. Yeah. Now if I try to print address of p, can you see DFF0 and DFF0. So this is what internally it calls, right? So that means even constructor is also one of the function. The name of the constructor and the class name both are same. That is the only difference. So how it internally predicts? So internally what it does is, so it will call a function point. So then it will pass address of p. So this is what internally it will change. So that means obviously this p is nothing but some instance. So that means what happens? So even this is also some variable. This p, it is internally kind of a structure, right? So internally it might have done structure point p, something like this. So then it is calling some function p and passing this address p. So this is what internally it might have done in a C++, right? Sorry, in a C, right? So this is what it internally happening. Got it, right? So this is what like I want to prove that one. The print does not belongs to any of the instances. But what if I have a static void foo? I'm creating one more function which is a static. I'll say cout and I'll say I'm inside foo \n, and also I'll try to say this m_x. Let us see what happened and quit this one, come out. Let's say g++ main.cpp. Can you see this is unavailable for a static member? So this is not a argument which is present inside this foo. So that means compiler will not create something like this, and there is no argument passed to the static function. So that's why you cannot access m_x here. Can you see? So even now, if you try to compile this one, can you see m underscore x, invalid use of member m underscore x in static member function. So that means even this one also you cannot access, because this foo is an independent function. How it knows like m underscore x, correct, right? By marking this function as a static, we are removing this argument from this function foo. So this is what it means. But how can I call this one? So in order to call this one, either you can call an instance dot foo. This is valid. So internally what it does is simply it will call foo. So this is what internally it does. So it does not even pass address of p. Just it is an convenience for the user and gives a feelings to the user that p belongs to this foo belongs to p. Now if I try to compile and execute, it all works fine, right? I'm inside foo. So now one thing I want to tell you is even this is also not required, since the instance itself is not required for the static function. So what I can do is I can simply call point and scope resolution foo. So earlier I was telling this foo belongs to p. Now I'm telling the foo belongs to something called point. This is the class. So this is a scope resolution operator, and foo is scoped inside this point. So if I try to compile and execute, so it is all working fine. Now what I'll do is I'll have a gdb -g3. I'll put like a gdb a.out, and if I put a breakpoint on foo means line number 21. So let's put our line number 21, and let's put a breakpoint on line number 33, and let us run. Can you see p.print has been came, and if I say next, and now it is about to execute foo. Now I'll try to say next. Can you see? So it has called this point foo, but there is no argument over here. So even if I try to print this no, so there is no symbol this in the current context. So that means inside this function, I am not finding a variable or a symbol which named as this. So this is the meaning of static. So that means whether it's a static function or whether it is a normal function, so it does not belongs to any of the instances. So that is what I'm gonna prove. So that is what I'm gonna tell you about. So the same thing apply for the things whenever you are trying to create a new instance. Yeah guys, hope you like this video. So if you like this video, please share and subscribe. Thank you.